Hi everyone, welcome to this video tutorial. We're going to continue our study of linked lists. Today we're going to have a look at doubly linked lists. A doubly linked list is a list of nodes. Every node has a pointer to the previous node in the list and the next node in the list. The first node's previous pointer points to null, and the last node's next pointer points to null. I've updated the node class to take into consideration our new friend, the previous pointer, which we set to null in the constructor, and of course we need to create accessor and mutator methods for that new attribute. What we're going to do in this tutorial is look at how to insert a node into a linked list, and we're going to adopt an approach where we're going to ask ourselves these 4 questions. Now there may be other ways of inserting into a doubly linked list, maybe more efficient ways. Please feel free to go and research them. I'm adopting this approach because for noobs like you and me, it gives us plenty of opportunity to practice the concepts of traversing a linked list and inserting and other operations. Okay, so let's get started. As before, we've got a global variable here which represents the external pointer to our list. We set it to null at the beginning of the program, and now we're going to construct a new node. This time we're working with nodes of integers, and we're going to send that node to an ordered list in order to insert it. Okay, so let's jump down into our ordered list design. The approach that I'm going to adopt is a series of 4 questions. The first question is the list empty? Now we've seen this before. Okay, if root is null, we're just going to say, hey root, you're now going to point to the new node. That's all we do, the same as before. We don't have to update any of the new node's pointers. They're still going to be null because it's the only node in the list. It's the first and the last node. Okay, so once we've done that, we can just return out of that function and we're finished. Second question we're going to ask is, do we have to insert the node at the start? That would happen, of course, if the value in the new node is smaller than the current smallest value. Okay, so let's do that. If the new node's value is smaller than this node that root is currently referencing, was it get value or was it get data? Maybe it was get data, wasn't it? Let's just change that to get data, just so we're consistent with the unit. If that's true, we're going to insert this node at the start of the list. And let's just take a very quick look at how to do that. Just going to move all of this over here for a second. And let's move this, and let's try and visualize what we need to do here. Okay, so the new node's next pointer is going to point to whatever root's next, whatever root was pointing to. So let's do that. New node dot set next is going to be whatever root was referencing. Okay, now whatever root was referencing, set previous to the new node. That's now pointing to the new node. So root dot set previous and I think the final thing we have to do is just say, hey root, you're now pointing to the new node, which is now the first node in the list. Okay, so with these 3 operations we can insert a node into the beginning of a doubly linked list. And now that if we have to do that, let's just return out the function because we're done. Now, do we have to insert at the end? This is a little bit tricky, the way that I'm going to go about this, but I'm going to do it anyway. Okay. Let's create a search pointer. And assign it to whatever root is. And let's start our while loop. While search pointer doesn't equal null, tell you what, let's just try and find the insertion point. Okay, let's see if we can find this node here, the node with 9 in it, because we're trying to insert 8, okay? And search pointer dot get data is less than new node dot get data we're going to update the search pointer. Okay, and that's going to take us through the list. Okay, now if we reach null, that means that whatever's in this new node is the greatest value. It's bigger than 17 because we continued on. So if search pointer is null, that's kind of a special condition. Now this is where my approach is going to be a bit annoying to you guys, because if we reach null, we've gone too far. We have to go back and try and get to this node. Okay, there's no way back. Okay, so what I'm going to do is I'm going to say, I'm just going to create a new node called, let's call it try again, and assign it to root. And while try again, dot get next. This time we're going to say dot get next doesn't equal null. That's going to take us to this node. Okay, we're not going to go to null this time. Maybe try again isn't the most appropriate name for a variable. There we go. Okay, so that's going to take us to this node here, and to insert this new node, which we're imagining that it has the biggest value, for example 18, what we're going to do is we're going to set its previous pointer to be search pointer, and we're going to update search pointers next to be the new node. Okay, so search pointer, I didn't call it search pointer, did I? Oh yeah, I did, because we're in this while loop, aren't we? Sorry. Yeah, try again. It's not search pointer. It's try again. Try again dot set next new node, and new node dot set previous. Try again. Okay, we're pointing this back to this node here, and we're pointing this one to here, and this is now the last node in the list. Okay, so when we did that search, if search pointer is null, we need to go and get a reference to this node, else if our original search pointer isn't null, that means we found a location somewhere in the middle. Okay, so for example, we should have found this situation here. I'm going to put this into here. Right, so we can see let's just make sure we know where search pointer is. We're imagining that search pointer has arrived at this node. Okay, now it looks like we're going to have to update 4 pointers, right? So search pointer dot set previous, this is now going to point to the new node, so let's just do that. So that's that one done. What else do we need to do? New node dot set next is going to point to this one, which is search pointer. new node dot set previous is going to point to search pointers dot get previous, because that's what that one's pointing to. We don't have a reference to this node, but this previous pointer helps us. Okay, so new node dot set previous is search pointers dot get previous. Now there's a nice little bit of code. Okay, so we've got one more. Which one do we have to do? We have to do this one, don't we? Search pointer dot get previous dot set next. And we're going to set it to the new node. Wow. See if you can get that working, guys. Will this function, look at that, will this function allow us to build an ordered doubly linked list of integers?